Alright, welcome 8th graders, lesson 60, area of a parallelogram. As you remember, if I was doing a rectangle, I'd multiply its length times its width. So area equals length times width. That's for finding the area of a rectangle. If I were to find the area of a triangle, put a triangle in here. The area of the triangle, we use a little bit different terms. The area here of the triangle equals its base times the height. So the base is this down here, and the height is the distance from the bottom to the peak, to the highest point in the triangle. And then we'd have to divide that by 2, or multiply it by 1/2. Wouldn't matter. So that would be the area of a triangle. Now a parallelogram is a little bit more like a triangle. Remember, a parallelogram has 2 parallel sides, 2 sets. So this side is parallel to this one, and this one is parallel to this side over here. But it's not going to take up as much area as a rectangle would if it was standing straight up. So for the area of the parallelogram here, again, we do base times height. Base being the distance along the bottom here, and the height being how high it is from the bottom to the top, not if there was a number on this line. So for instance, here in this type of problem, we could see something like this. Let's say this is a 10 for the distance, bottom, and let's say the height is a 5, and the length of this side over here is a 6. Well, to find the area of this parallelogram, we would not use the 6. We want to use the height, not the length of this side over here. So 5 times 10 would equal 50 units squared. So parallelograms are like that. Alright, this is just another way to show 8th graders exactly what we're talking about. Over here we have a rectangle. Height is 6, the length is 10. So if we counted up all the squares in here, we know that we would get a total of 60 squares in there. Over here we have the same type of rectangle. This length is still 6, it's still 10, but it's started to fall down. As you can see, it's kind of like it's leaning this way and falling down. So the height is now only 5 of those squares. And if we add all of those up in the middle, or we did the multiplication there, we'd find that in here we only have 50. So what we want to be sure of is not to, on a parallelogram, use these numbers outside, but use the actual height on the inside, because as you can see, between the two, this one looks smaller visually, even though the length of the side might be the same. In the inside, they are very different. They have different amounts of area. Alright, let's take a look at example 1. We've got a parallelogram here, and its height, and they'll usually put a little 90-degree symbol showing you that straight up and down. The height here is 5, this is 8, and this is 6. So they want to know the area and the perimeter of the parallelogram. Well, for the perimeter, we are allowed to use the 6. So the perimeter will be 6 plus its opposite side of 6 plus 8 plus another 8. So we add those together. 8 plus 8 is 16. 6 plus 6 is 12. So 16 plus 12, that'll equal 28 centimeters. Now the area is the base times the height. The base is 8. The height is 5. 8 times 5 is 40 square centimeters. So that's example 1. Example 2 here. Alright, in example 2 then here I've got this first parallelogram, the small one, A, B, C, D. I've graphed those coordinates. And now they say graph a dilation. Dilation means to get bigger with a scale factor of 3. So I need to multiply all of my coordinates by 3. So we can do that here. So the first one we have, I had 2, 1 over here. So 2 times 3 will be 6, and then 1 times 3 will be 3, so we can start up here. Okay, for B, that was 1, negative 1, so it'll be 3, negative 3. So out 3, down 3. C was negative 2, negative 1, so that'll be negative 6, negative 3. 2, 4, 6, and then negative 3. And D was negative 1, negative 1, so that'll be negative 3. Positive 3. So now I can go ahead and connect all those to form my new dilated parallelogram. A prime, B prime, C prime, and D prime. And then C asks the area of the image is how many times the area of the parallelogram and why. Well, I could come in here and say this is a base of 1, 2, 3 and a height of 2, so this is 6. And this one down here is 1, 2, 3, 4, 5, 6, 7, 8, 9, and its height is 1, 2, 3, 4, 5, 6. So 9 times 6, that will be 54. So how many times bigger is the area when I dilated it times 3? Well, the area is 9 times bigger. If you remember from last year, we increased the area, so we increased, the dilation was 3, and when we deal with area, we're always squaring things. Well, 3 squared is 9, so our area should be 9 times bigger, and it is. Alright, that's it for today. You guys can get started on your practice set.